so thank you for the kind introduction. And yeah, now we are traveling to Denmark and discussing control measures to limit the spread of LA-MRSA among Danish pig herds. And first of all, some words about livestock-associated methicillin-resistant Staphylococcus aureus. It's a pathogen, or MRSA is a pathogen most of you might have heard about already. It can lead to severe infections in humans, mainly because of the resistance against methicillin and other antibiotics. Here we mainly deal with the livestock-associated version of MRSA, which mainly occurs in pig herds. The pigs do not show any clinical signs. They are just colonized in the nose and behind the ears, but there are a lot of reports about transmissions from humans to farm workers and also to slaughterhouse workers. And from there, MRSA spreads into the community. And that's why we are talking about this. Yeah, so what is the current situation in Denmark? Here you can see a map, a figure showing the number of MRSA infections according to the epidemiological classification. And you can see that in 2019, about 1/3 of the infections are related to LA-MRSA, which is coming from the livestock. Now PowerPoint does not want to work anymore. Sorry, but I can't change the slide. I try to close PowerPoint again and share the screen again.
You don't have a PDF version of your...
No, I don't have, sorry. Okay. But I try to share the screen again. So here we go again. Yeah. Can you see it?
Yeah, it's okay. It's the first.
Oh, so now I can change the slide again. Sorry for that. So the next figure just shows the development of positive pig herds. And between 2008 and 2016, the number of positive herds increased dramatically. And at the same time, the number of humans affected from LA-MRSA increased for humans with livestock contact, but also for humans without livestock contact. And in Denmark, this topic reached a high media attention, and in the end they blamed pig movements to be responsible for the development in the pig herds and indirectly also for the development in the humans. And that's why the government set up an action plan to limit or to reduce MRSA infected pig herds, for example, by reducing the use of antibiotics. However, this action plan was not super successful, and that's why they decided to start a research project. And this research project included a simulation model, and that was my part. And we wanted to answer the questions: how can the increase in LA-MRSA positive pig herds can be explained, and why didn't the measures lead to success? So, how can LA-MRSA be transmitted? So if you have it in one herd, then of course the pig movements could be one reason for transmission to another herd, but also LA-MRSA could also be transmitted via humans and vehicles and equipment. And MRSA was found in soil, in flies, rodents, companion animals, and in the air. And there's some likelihood or some probability that there is transmission also in the local neighborhood of an infected herd. So we had to decide which transmission paths should be included in our simulation model. We had to check what data and information was available, what time period are we looking at. Then we decided on two goals. The first one was, again, to better understand the transmission routes. And the second goal was, what effect would potential control measures have had? So we decided for a study period between 2006 and 2015. So this was a retrospective study, and we had about 13,000 registered pig herds in Denmark during this time period. And from each herd, we had the herd type, the numbers of sows, weaners, and finishers that were registered in the herds. And we had information about the risk of the use of high-risk antimicrobials. And as this was a pretty long time period, we decided to update the information every year about opening, closing of the herds, if they changed operation mode, if they updated the herd sizes, or if they had changes in the use of high-risk antimicrobials. But we didn't have any information how LA-MRSA came to Denmark. But we had information about LA-MRSA screenings in herds. So one was performed in 2008 and one was performed in 2014. And in the first one, no breeding herd was affected, but they found 4% of the production herds positive for LA-MRSA. But in 2014, already 60+% of the breeding and production herds were positive for LA-MRSA. And during the whole research project, there were some phylogenetic analysis, and they revealed that in Denmark, there were mainly 3 strains circulating, and 2 of them were estimated to be present already in 2006. And 1 might have been introduced later, maybe around 2009. So we developed 17 different initialization scenarios where we decided to start in breeding or in production herds. We varied the number of herds that were initially infected with LA-MRSA, and we had scenarios where we only seeded our infection once, or we seeded at different points in time. Within the herds, we used a 3-compartment SIS model. We used transmission rates from literature, and we had 2 different sets of transmission rates, one for herds using high-risk antimicrobials and a set of transmission rates that were lower for herds that were not using high-risk antimicrobials. And then we implemented different transmission routes. The first one was based on the registered pig movements. Within our study period, we had about 1 million movements where we had information about the sending and receiving herd, the date of the pig movements, and the number of pigs that were moved. But we hadn't information about the age group of the pigs moved, and we decided to estimate or to figure out which age group is affected based on the herd type. Then we tried to model transmission via farm visitors, but information was sparse about how often and how effective those contacts might be. So we used the information we had and asked experts to estimate the transmission parameters. The same holds for abattoir movements. We had the information that there are some shared transports to the slaughterhouse where vehicles move from one herd to another to pick up the pigs for slaughter. And again, we asked the experts how effective this might have been. And we decided to include transmission via farm workers that work at different herds under the same ownership. We didn't explicitly model the environment. However, we tried to include this in our initialization scenarios, as there is some kind of uncertainty in there. So the first goal was to better understand the transmission routes. And as the pig transports were blamed to be responsible for everything, we modeled our transmission of LA-MRSA among the herds only based on transmission via pig transports. And then we checked for all of our initialization scenarios how the estimated herd prevalence in the production herds in 2008 matched to the screening results. So this gray area just represents the screening results. And when I add the simulation results of our 500 simulation repetitions, I highlighted all the violins in red where the median matches the screening results. And as you can see, we are just with default standard parameterization, at least in the area where we expected or where we wanted to be. However, when we check this for 2014, just as a reminder, we had about 68% of prevalence in the production herds at that time. And independent of how much we seeded and how often we initialized, we didn't end up close to what we predicted. So of course, we also run the model with all the implemented transmission paths, which I mentioned before, and all the interactions. And again, the figure for the production herds in 2008. And as you can see, we are still in the correct range where we wanted to be. And also in 2014, we were getting closer to what we expected. So some of the scenarios were able to some kind of match the data we observed. So we try to investigate the proportion of transmissions, and here the pig movements are in gray, and we're responsible for about 75% of the transmissions. However, without the interaction with all the other transmission routes, we were not able to mimic what happened in Denmark. So they are interacting and the pig movements are important, but without any other transmission, it's not possible to mimic what happened in Denmark with our model. And of course, we ran a sensitivity analysis, and we found out that the frequency and effectiveness of the contacts by visitors was sensitive, as well as the spread of LA-MRSA within the herds. So the next step was to add control measures. And as the pig movements were important, we said, okay, let's model some movement restrictions. We mimicked that all herds were tested once per year or 4 times per year. And then if a herd was tested positive, we stopped, or we didn't allow anymore the transport from a positive to a negative herd. The second control measure we implemented was the increased biosecurity. We modeled this by reduced transmission rates based on the human visitors, and we reduced this probability by 50% or by 75%. And then we added a reduction of high-risk antibiotic use in 50% of the herds or in all herds. And finally, we set up an eradication program. And in one scenario, we randomly selected the herds that went into this eradication process. And in the second scenario, the selection was risk-based. So what effect would potential control measures have had? Well, we investigated this in 2 different scenarios. One where we started the control at a prevalence of about 5%. It's the early start, and the blue violin represents a prevalence of about 25% when we start a bit later with our control measures. And without any control, we can see that the prevalence would increase in both scenarios when we ran the model for 6 years. And then we implemented all control measures individually. And then we measured the relative reduction which we observed. And the highest values were observed when we stopped using high-risk antibiotics in all of the herds. And Yeah, when we combined two control measures, this reduction is even higher and already at a very, very high level. And especially when we start at a higher prevalence, we are already able to reduce the, to stop the increase of positive Hertz. And then, of course, we tested also combination of 3 control measures and all 4 control measures. And when you implement very intense control measures, you are able to keep it on a very low level or even to decrease it. But you, at least in our model, we weren't able to eradicate it completely in a time period of six years. So to sum up, control measures show effects, especially when you combine them and when you use very intense control measures. But of course, this is depending on the herd prevalence at the start of implementation, and of course, dependent on the duration of the implementation. So I would like to thank some colleagues, and I'm happy to take your questions.
Thank you, Jonna. It was very interesting. I was noting the idea of questions, so I'm a bit late. Is there any question from the audience? So again, you can raise just your hand and talk. So I will start and they will have questions for sure. Maybe a first question would be, because, well, your results are very interesting. You go in full detail about the different combinations of interventions and transmission routes and so on. But finally, to your opinion, in practice, what would be feasible? Because we all know that when you have interventions that are at a high level, sometimes it's just very hard to implement in the field. So do you think something like that could be implemented, or something less, and what impact it could have on the time to really reduce the prevalence?
Well, it always depends on the motivation. So there was an economic analysis performed in Denmark as well, and they revealed that it would cost very, very, very much money to get rid of MRSA. And in the end, well, you need the motivation to implement something that doesn't affect the productivity of the pigs. So the farmers might not be too willing to do something about this. And that's why this is really hard to answer. And actually in Denmark, they didn't change the action plan. Until now, they still try to reduce the antimicrobial use in the herds, but this is, yeah, they try this everywhere. It's not directly related to MRSA. And yeah.
Because your model could be very helpful if there is any discussion with a group of farmers or stakeholders to decide which measures could be implemented because of not too high cost, because they have no loss on farms. So and then implement that in the models to see, okay, what should be combined if it's low level measures, what should be combined, and to which kind of expectation at the end. So how long to reduce the prevalence up to a given level. So I think your model is very useful for that, and it would be very interesting to open the discussion with the stakeholders, even if it's, well, not that easy.
Yeah, the point is that this is just a general view for all the herds in Denmark, or at least for the production and breeding herds. And if so, I think you need regulations on the whole country scale and not just on individual scale, because then I think some farmers are more aware, some are less aware, but you could increase the awareness, and they have to have a good biosecurity, but they already know because of other diseases and so on, or they should know. And the same holds for testing the pigs before they import them. They know that this is a risk to get diseases in. So it's still not affecting the herds. That's a problem.
A second thing I found very interesting is that you highlight that pig movement was really needed for starting something, for starting the spread of the pathogens. And then that other routes were needed to amplify the problem. And how do you think you could use your model to try to better rank the different routes in terms of involvement in the starting and of the spread and involvement in the amplification events?
Yeah, it could be used. The problem is that the information about all these other transmission routes is really sparse, and there are a lot of knowledge gaps. And we asked experts about this, and most of them just answered, "We don't know. It depends on the people who are going there." So we have seen that you need a random spread over the country, and then it's just maintaining itself with the peak movements. That's okay. But without those random events, we weren't able to mimic what happened in Denmark. So the rest is more for the to-do list in future.
You have a question from Colin in the chat I can read. It's interesting that avoiding some antibiotics can reduce LA-MRSA. Please, can you summarize how that happens again?
Well, when we mimicked or simulated that we reduced antimicrobial use, then we just mimicked that there were lower transmission rates in the herds. And this was already described in literature, so they found it on farms. And in the end, every measure that would reduce the spread in the herds and would reduce the transmission within the herds would have the same or similar effect. So yeah, that's mainly the strategy behind, or the mechanism behind. Yeah.
Okay. Any additional question from the audience? Well, yeah, Lisa?
Yeah, thank you, Jana. I have a question that is maybe beyond your presentation. I was wondering if you thought about including a within host model accounting for the competition between this kind of bacteria and also the microbiota, because as far as I know, they're often present in the animal bodies, and then they sometimes, in some circumstances, they become and pathologic. So
actually, well, we discussed about this in the whole project group, because it is a topic. Yes, there's a second simulation model that was only dealing within one pig herd, and they tried something like this to
relate the within host.
Yeah, to relate exactly. But it's really hard because there's still a lack of knowledge regarding all the little details you need to model it in a proper way, because you have in the end, this is very individual for each pig. And then yeah, it's not an easy task. So
okay. And do you know if there is some publication on this model? Or I would be interested. That's why I'm asking.
I don't know if they are already published. Yeah.
Okay.
Yep.
Yeah. Thank you.
Well, thank you, Jana, for the talk and for the discussion.